Okay, in this video I'm going to show you how to evaluate a function, which is really not a big deal, but if you've never seen it before, it's kind of weird. So we have a function, f of x is 2x squared minus 3x plus 4. So what I've done here is I've colored all of the x's in green to kind of highlight what's happening. So key thing here is this is not multiplication. So on the left-hand side there, that's not multiplication. It's not f times x. It's actually a new notation. It's f of x. So the way it works is, let's just do an example, I guess. So we want to evaluate the function at x equals negative 2. So I need to know what notation to use for that. So that's going to be f of negative 2. So what I'm going to do is I replace the x on the left-hand side with negative 2. What I'm going to do is replace every x that I see on the right-hand side with negative 2. So let me do that. So there's a 2 in the definition of the function. Now there's an x, so I'm going to replace that with negative 2. So I'm going to put parentheses, negative 2, close parentheses. And then what was I going to do to that x? Well, I have to square it. So squared. And then minus 3 is another part of the definition of the function. Here's an x again, so I'm going to put it in parentheses, negative 2. And then at the end I just have to add 4. So plus 4. And now it's a matter of remembering your order of operations, things like that. So 2, the quantity negative 2 squared, so that's negative 2 times negative 2, that's going to be positive 4. So 4. A negative times a negative is a positive, so this is plus 6, and then plus 4. And then if you look, the easy way to simplify this is we have 8, a 6, and a 4. 6 and 4 is 10, so it's really just 10 plus 8, so 18. And then usually what you do is you want to make sure everyone knows exactly what you did. So we evaluate f of negative 2. I'm going to do one more that's a little different, just to kind of highlight that you can actually replace x with anything. So in this question, what I want to do is I want to evaluate that function at x plus 1. So this is weird, but let me write the correct notation for it, and it becomes a little clearer what I need to do. So it's going to be f of x plus 1. So what that means is every x that I see in the definition of the function, I have to replace with x plus 1. Why would I want to do this? Well, you'll get into that more when you take a little more algebra, but let's do it. So 2 is in the definition of the function. If you see an x, you replace it now with x plus 1. So it's going to be the quantity x plus 1, and then squared is part of it, part of the definition of the function. There's a minus 3 that's part of the definition. Here's an x, so I have to replace that with x plus 1. So I'm replacing all my green x's with purple x plus 1s. So there's x plus 1, and then this plus 4 just kind of hangs out on the end. So now what I need to do is I need to remember how to expand x plus 1 squared, which I'm just going to do. Get x squared plus 2x plus 1. I'll show you in a minute how. One way of doing that, I actually just have memorized how you expand those, which is a great idea. But if you don't, I'll show you a way that you could use. So it's minus 3x and minus 3. So we're distributing negative 3 to both x and to positive 1. So we get minus 3x minus 3. Don't forget to distribute the negative as well as the 3. And then still plus 4. I'm going to distribute the 2 to everything in parentheses there. So I'm following the order of operations, really. Rewrite that. Now I'm going to go through and collect like terms. So there's only one squared term, so 2x squared. And then I have a 4x, and then minus 3x leaves me with x. And there's nothing else, so I just have plus x. And then there's 2, minus 3 is negative 1, plus 4 is 3, so plus 3. And remember, you want to remind everyone what you did. So what I just did was f of x plus 1, put it in a box. So let me show you one way that you could expand x plus 1 squared. The ideal thing to do is to memorize it. Memorizing it, it's the first thing squared, so that's where x squared comes from. Multiply the two things together, so that gives you 1 times x, and then double that, so that's 2x, and then square the last, so that'd give you x squared plus 2x plus 1. But if you don't know that, one thing you could do is you could set it up like a normal multiplication problem. So if you know how to do normal multiplication, this would work for you. If you learned some weird alternative method, I don't know what you would do. But anyway, I've set it up like this, stacked them. So in normal multiplication, what you do is this first thing here times this first thing up here, right? So 1 times 1, that's 1. And then you do the first thing, so that's that bottom one again, times this top thing, so x. So 1 times x is just x. So I have that. And I'm done with that, right? So now I move on. So this is just like normal multiplication, like take two two-digit numbers and multiply them. You'll be doing the same thing. I'm going to take this x, multiply it by 1, so 1 times x is just x. And then I'm going to take this x, multiply it by x times x is x squared. So I have that. If anything ended up negative, there would have been a minus sign already involved. So I'm going to go through and put plus signs to make it a little clearer. And now what I'm going to do is just add down the columns. So I get x squared plus 2x plus 1, which is what I had that I substituted in. So memorizing it is better, but if you don't memorize it, this idea of stacking them and multiplying is actually really useful because it'll let you multiply pretty much anything that looks like that, and that's going to be useful to you later on. Anyway, that's how you can evaluate functions. Hope you found it useful, and good luck.